how to use the scope. This is a typical oscilloscope setting that you may see when you're taking measurements. The way that you look at this is you have volts per division. It would be set at 2 volts for this particular one, and the time per division or seconds per division is 0.5 milliseconds. So let's take a look at what this means. If you have 2 volts per division, that runs up and down on the horizontal axes. So this is 2, that would be 4, that would be 6, minus 2, minus 4, minus 6, going up and down. The seconds per division run on the vertical axes, and each division is 0.5 milliseconds. So this is 0.5, this is another 0.5, so that would be 1 milli. This is another 0.5, that would be 1.5. This is 2 milli, and this is 2.5 milli. Alright, so anyway, the question asks, what will you read on the digital meter set to AC volts? So the digital meter set to AC will read an RMS voltage. So what we need to do is, from the scope, we need to find the peak voltage and then convert the V. We need to convert from VRMS is 0.707 times the peak. So we just figured out that each division is worth 2, so, and this is the peak right here. Let's go over here. So this is 1, 2, 3 divisions at 2 volts each, so that's going to be 6 volts peak. So my RMS value is going to be 0.707 times 6 volts. So let's take a look at the solution. Well, they did this a little bit differently. They found peak to peak, which is fine. You could just use a different conversion. But anyway, the answer is 4.2 volts. Is the frequency response an issue? No, the frequency is only 400 hertz, which is within the range. So how do they get 400 hertz? Well, the period of the sine wave goes from here to here, the positive plus the negative. So it's 1, 2, 3, 4, 5 divisions. 5 divisions at 0.5 each. So that's going to be equal to 5 times 0.5, which is 2.5 milliseconds for the period. So the frequency is 1 over 2.5 milli, which is 400. This is a common problem when we're using the hookups for an oscilloscope. A student hooks up the oscilloscopes as shown and is surprised to find that there's no channel on channel 2. So channel 2 is the red one. Notice the line is straight. We do have a blue signal. The blue signal, I'm not sure what the volts, I can't quite see that. But anyway, it goes up 3 divisions. Whatever it's set at volts per division on channel A, or channel 1 would be times 3 divisions. So what's wrong with this? Well, the problem is this. The grounds are not the same. When you're looking at your oscilloscope, you have to have the same grounds. So what you'd have to do is you'd have to either move that ground to here, but then you're not measuring VR1. But the way you could calculate VR1 is you could take the source minus V2. You measure V2 on the red. And this here, the blue one, if you go from this point to this point, is going to measure total. And that's exactly what they say. The scope grounds should be together. The channel 1 ground has shorted out resistor 2.